Luke Jennings implemented this in 2007, presented it at CCC. And what this basically is you've compromised a couple of machines, you're administrator on them, maybe a couple of workstations, you elevated your privilege to other workstations because there were some shared passwords, and you start looking at who's logged on to those workstations. And are there interesting people there? And an obvious interesting person is a domain administrator. So say you compromise a server where a domain administrator is logged in, or even a workstation where he just is working at, or he doesn't even have to be at the console. He left the session open, and you've compromised the machine. So what Luke Jennings' tool does, Incognito, is it looks at who's logged in and looks at their access tokens, which is basically a way for Windows, a token which you can use to authenticate to other systems. And Windows basically has this in memory, and it's basically sort of your hashes cached in memory. And if you're a local system or administrator on that machine, you can take over those sessions of those users. So if you take over a session of a domain administrator, suddenly you are the domain administrator. If he's logged on to that machine, you can execute commands on its behalf and add users to the domain, things like that. Of course, you could also install keyloggers and do it that way, but this is a lot more convenient and really instant. You can even automate this. So he has a really nice paper. I'll list it at my blog at the references, and if you're interested in this, it's a good paper to read. So, if you've managed to do that, and you're on the domain controller, and obviously there are a lot of different paths that can lead up to this situation, but this is usually an easy one to use, and it usually works in most networks. What you can do now is harvest even more passwords and make your way into other connected domains, for example, of neighboring companies, try to crack passwords and use those to get into Unix systems, maybe network components, things like that. But sometimes you don't even have to crack those passwords. I'm not sure if you can read the last part with the checkbox, but it says store passwords using reversible encryption. And this is something that Windows actually allows you to do. What it does, if you tick that box, and you can tick it for a single user or even for the entire domain. And if you tick that box, Windows stores the hashes for that user, the NTLM hash and the LM hash if that's still enabled. But it will also store the password in an encrypted form, but in a way that it can reverse that encryption. So it's not enabled by default, but you can enable it by just ticking a box. And you may wonder why. Why would anybody in their right mind ever want to recover those plain text passwords? Why would you ever need them? There are actually a couple of authentication protocols that require you to have the plain text password in order to confirm that the user has the correct password. An example of that is HTTP digest authentication. You can enable this on IIS servers, for example. Ticks the box. I want this directory to be protected not by basic authentication or NTLM authentication. I want digest authentication because I think that if you think you need crypto or something, because it does some crypto, and you don't have SSL, for example. But Windows will tell you, hey, you can do this, but I'll need to store the passwords using reversible encryption. Another example is CHAP. If you have a VPN, for example, or even dial-up, and you do CHAP authentication, Windows also needs the plain text password to authenticate that user. And how that works is basically, client tells the server, hey server, I'm Bill, I want to authenticate to you, I want to give you my password so you can confirm my identity. Server says, okay, no problem, but I don't want you sending your plain text password because people might intercept it. I also don't want you sending a hash of your password because, well, people might intercept that and use that to authenticate. So we're going to do a little challenge response thing. The server sends a challenge, which is basically a big random number to the client, and the client takes that random number, adds his password to it, hashes that whole thing, and sends it back to the server. So in order for the server to confirm that that user has the correct password, he needs to recreate that hash and compare it to the hash he has just received. So he needs the challenge to create that hash and the plaintext password. So this is one of those situations where you need the plaintext password. And this is a bit of oversimplified diagram, but you get the point. And this is not MS-CHAP, by the way, or MS-CHAP v2. This is regular CHAP. With MS-CHAP, you don't need to store the plaintext password. So when I first heard about it, I thought, well, who cares? Nobody uses this. Who would enable this on their domain? Why would you use CHAP? Why would you use digester? There are other things out there that are just as good or better. But then you start seeing it in the wild. People actually use this. They enabled it for a couple of users because maybe they checked the box accidentally or something, or for the entire domain you see it sometimes as well. So I decided to do a little research, a bit of reverse engineering, looking at those binaries involved and seeing if I could figure out how does this thing work and where are those passwords actually stored and does it create any additional risks. So I started looking at this process and I enabled it on a testing domain and started looking what processes are involved and what DLLs are involved. And I came up with this one, it's res-sfm.dll. And this is a password filter. And what password filters are is there are a couple of DLLs that are listed in the Windows registry. And when you type in your password on a Windows system and Windows tells you, oh, that's not good enough, that's way too short, or it's not complex enough, that's actually a password filter telling you that. So Windows sends that plaintext passwords to all those DLLs that are listed there, and the DLLs tell Windows, oh, that's an okay password, or I don't like it, ask the user for another one. So it's actually a pretty nice place for a backdoor as well. You can create your own password filter and place it there and intercept plaintext passwords when users change their password. But anyway, I decided to reverse engineer this one, debug it, disassemble it, to see what it actually does. And as it turns out, this password filter, this particular one, always tells Windows, well, that's a great password, I love it, use that one. So it doesn't actually check the password, but in the background, it stores it using that reversible encryption. And when you enable that, you'll see in Active Directory there's a new binary blob there for each user that you enable this on. And it's called user parameters. And as I said, it looks pretty binary, but you see a couple of text strings in there. One of those is gradius chap, and the other one is gradius chap key. If you find it in your Active Directory, that user parameters one, it doesn't mean that there's reversible encryption there. It's stored for other things, such as terminal server profiles are partially stored in there. But if you find those two in there, then yeah, that's reversible encryption. And it also creates a global LSA secret. And what an LSA secret is, it's a way for Windows to store secrets, basically a Windows API. And if you're a programmer, you can tell Windows, hey, I want to store this secret, and I'll give it this name. You don't give it the password or anything. Just give it the name and the secret, and Windows stores that for you in a secure place. And if you know the name of the secret, and you're a domain administrator on the system where the secret is stored, you can retrieve that secret. And there are a couple of tools out there to list those secrets. Kane does